Hey guys, this is Monica, and today I'm going to be going over this problem from the given article, Student Understanding of the Ideal Gas Law, Part 1, A Macroscopic Perspective. And the question that I'm going to be covering is the one on the insulated cylinder. And the problem reads, the insulated cylinder problem. A cylinder with a frictionless piston contains an ideal gas. The cylinder is placed in an insulating jacket and small masses are added. The students are asked whether the pressure, temperature, and volume of the gas will increase, decrease, or remain the same. They are asked to explain the reasoning. So for this problem, we are using the ideal gas law, PV equals nRT, to try and relate the relationship between pressure, volume, and temperature. And as we know, we are assuming that the amount of moles in the container will not change, and we also know that R is constant. So from the article, some very common mistakes that the students made during the study was one, assuming that adiabatic processes cannot have a change in temperature. And basically what adiabatic means is that since this is an insulated cylinder, there is no transfer of heat from inside to outside or outside to inside of the container. So all the heat energy will stay inside, and all the energy or heat from the atmosphere or outside of the container will not affect what's going on inside. But they also missed that when the internal energy increased, temperature also increased. And many of the students actually did know this, but they mistakenly assumed that because it was an insulated cylinder that this meant that the temperature couldn't change with it, which is actually incorrect. So the correct way of actually wanting to go through this problem and to think about it, so we know it's easy to understand that pressure increases when the volume decreases, and since this piston here is not fixed, the more mass we add to it, the more the volume is going to decrease. So if we have a decrease in volume, the pressure will increase. And the best way I can explain this is by this small illustration here. So I have this bigger square with 5 particles in it, and if we decrease the volume of the square but keep that same 5 particles in there, we can say that there's more collision within this smaller square. So that means that the particles are hitting the walls more often, causing there to be more pressure within the system. And the correct answer about temperature is actually that the temperature will increase. And the way that I like to think about this is that since in the smaller square, there's more motion from the particles, and we know that at high temperatures, particles move really fast or they collide a lot. So we can also think about temperature increasing in this way. Since the volume is decreased, there's more collision, the particles are moving more, therefore the temperature can also increase. But we can also relate this to the internal energy, which is directly related to the temperature. So if our volume decreases, our internal energy will be larger, therefore our temperature will also increase. And then finally, I want to go over the word insulating. So this actually means that there's no transfer of heat, like I mentioned, and this is also adiabatic. So we want to note that even though there's no transfer of heat and that it's adiabatic, the temperature can still change.